Welcome to the Explainer. Listen, in Solidity, every single line of code literally costs money. And today, we're going to master storage versus memory so you can start saving some serious gas. Let's get right into it. So why exactly is your smart contract burning so much gas? Well, more often than not, it comes down to poor data location management. If you toss a variable in the wrong place, you're basically just setting your ETH on fire. To understand why, let's look under the hood at the Ethereum virtual machine architecture. It basically relies on three main areas to execute instructions. You've got your volatile stack and memory handling things on one side, and then, on the other, you have your persistent storage. Now, think of storage as the blockchain's actual hard drive. It's a persistent key value store, meaning your state variables are permanently kept there across all transactions. But since every single node on the network has to store this data forever, it comes at a massive premium. And when I say premium, I mean it. Just initializing a single storage slot from 0 to a non-zero value, that costs a staggering 10,000 plus gas units. Literally, just reading from it is wildly expensive. And that is exactly where memory comes in. Think of this as your temporary RAM. It's a volatile, byte-addressable workspace that only exists while a function is actually executing. And then, poof, it's totally erased. It's much cheaper and prioritizes quick execution. But beware, it expands dynamically as you use it, and those gas costs grow quadratically. So as a developer, the choice you make here is absolutely crucial. You have to intentionally decide between the persistent, super expensive storage for your state variables or the temporary, cheap memory for your local logic. It's a total balancing act. But wait, what if I told you there's a secret weapon? Enter CalData. This is a special, read-only temporary data location used exclusively for external function arguments. It's a game changer because it completely bypasses that memory expansion overhead when you're passing read-only arrays, saving you thousands. Okay, but you've got to watch your assignments closely. The rules here are strict. Moving data from storage to memory, that creates a safe deep copy. But if you assign a storage variable to a local storage variable, it actually creates a pointer, kind of like a symlink. If you modify that, you are accidentally overwriting the live on-chain state. You definitely don't want to do that by mistake. Another huge mistake? Repetitive reads. If you're reading a storage variable over and over in a loop, those S-load operations are just draining your gas. Instead, real-world optimization dictates you read it once, cache it into a temporary memory variable, and just use that. All right, here is your rapid-fire gas optimization playbook to take away. Ready? 1. Use call data instead of memory for read-only array parameters. 2. Cache those storage variables in memory for loops. 3. Use the immutable or constant keywords for fixed values. 4. Pack multiple variables into a single 32-byte storage slot. And 5. Actually use uint256 instead of bool to dodge those 0 to 1 initialization penalties. So let me ask you, are your smart contracts truly optimized, or are you just burning money on the blockchain? It's time to audit your code, master these data locations, and stop wasting gas. Get out there and keep building.